Okay, welcome back. This is 127 movie video for 12.3, section 12.3. I must apologize. There were some errors that hung over into the homework. There were quite a few errors at first, but thanks to Ryan, I think I caught the majority of them before most people got into the homework. So thank you, Ryan. And there were still some that hung over, so thank you for those that posted. But let's take a look at those. Again, I apologize for the errors. I typically go through and do the homeworks myself before I've posted them, but I haven't. So it's been evident that I haven't, and I apologize. So they're fixed now. I hope they're all fixed now. I hope there's no more errors. Let me know if there are, and I'll fix them. So let's take a look. We're in 12.3. Let's look at number 14 and 15. They deal with the same sequence. This was one of the errors that I wrote the sequence wrong. But the sequence should have been, and is now, root 2 over 2, and then 1, and it was missing this root 2 here, which made it not really correct. And then 2 and 2 root 2, and then a 4, and it goes on and on and on. Right? So this is the correct sequence. We're looking for number 14, we're looking for R, and then in number 15, we're looking for the general term, right? And so for R is just the ratio of any particular term divided by the previous term. So I can think of this as, say, 1 over root 2 over 2, but I can also think of it as root 2 over 1, and that's just root 2. And I should get root 2 out of all of these. Root 2 over 1 is root 2. 2 over root 2 rationalizes to root 2. 2 root 2 over 2 is root 2. So it happens everywhere. So that's my R, and that's the answer to 14. 15 is looking for that general term. We're looking for AN, right? But AN is always some constant number, whatever they call it, an A typically, times that R to the N. Right? I know R is root 2 here. And so I have to think what A will give me root 2 over 2, and that of course is 1/2, right? And so I can write this as 1/2 times root 2 to the N, and that is correct, but it's not an option in your homework selections, right? So I can manipulate that a little bit though. 2 is just root 2 squared. So if I think of this as a root 2 to the N in the numerator and a root 2 to the 2 in a denominator, I can call this root 2 to the power of N minus 2, just with a regular division. Right? That's how I get my powers. And that is an option in your homework, right? So that would be the answer to 15. Okay, let's look at number 16 and 17. Okay. Our sequence is -16, comma 8, comma -4, -2, and so on, right? And it's the same type of question. 16 asks for the common ratio. So you can take any of these. 8 divided by -16, that's -1/2. -4 divided by 8, -1/2. This should not be negative. That's a 2 divided by -4, that's -1/2, right? And so that's the answer, I think, to 16. 17 asks for that common ratio, or sorry, the nth term, the general term. And so that's some number multiplied by -1/2 to the N, right? Now I have to figure out what number is going to make this work. But if N is 1, I have -1/2, and so -1/2 of what number is -16, and that is of course 32. And again, this is correct, but it's not an option, right? So I can manipulate this by saying, well, what if I took one of these -1/2 and took it out and applied it to the -32? Then that's -16. And since I've applied one of these -halves, I have one less of them, and so I can write it as -16 times -1/2 to the n minus 1, and I believe that is an option, and that it would be the correct option. So there is some manipulation. Sometimes you'll have to turn these into another form that you didn't end up with. So that's how you do that. Okay, let's look at 18. 18 has a sum in summation notation. This is the Greek letter sigma. It's like a capital S for sum. And we go from n equals 0, that's our starting point, and our end point is 5. And the expressions are 3 times 1/2 to the n. Yes, okay. So we have a formula, right? And we have to be careful if I try to use this formula. The formula says, the formula uses an index of k instead of n. That doesn't matter. And it may be a little bit confusing because then it stops at n, right? So this n over here is the index, meaning whatever I have in here goes from 0 to 5, right? Over here, k is my index, meaning whatever k I have in the expressions starts at 1 and stops, in this case, at n, right? So they're just kind of variables, or parameters, dummy parameters that you have to just be careful which one's the index, right? But if I have some, let's say, I believe it's a times r to the n minus 1, right? Which is not the same form that I have. It's in summation notation, but I'm starting at 1, right, over here. But if I have that, then this thing turns into that a multiplied by 1 minus r to the nth power over 1 minus r, right? So in order to use this formula, I need to turn this summation notation into the same kind of notation over here. So what I really want to do is I want to take this and still say that it's a sum, but I want to start it at 1. And I still want 0 to 5, that's actually 6 terms, and so if I increase this by 1, I have to increase this by 1, right? And start it then 3 times 1/2. And I need to make sure that this is the same as what I started with. The very first expression up here would be n equals 0, and 1/2 to the 0 is just a 1, right? So I need the power up here to start off with a 0 despite that n is 1, and so I need it to be 1 less. And now I have it in the form that the formula is useful to me in, right? So I can plug that in. I can then say that the a is 3. 1 minus r to the n, well that's 1 minus 1/2 to the n. N is where I stop, that's 6. So that's 1/2 to the 6th, all divided by 1 minus r, which is in this case 1/2 again, right? And so I just need to simplify this, and that's my solution. 1/2 to the 6, well 2 to the 6 is 2, 4, 8, 16, 32, 64. So this is 3 times 1 minus 1 over 64, all over 1 minus 1/2 is just 1/2, right? This 1/2 I'm going to end up bringing up and multiplying then the whole thing by 2. So I'm just going to cram it in with my 3 and call that a 6. Now I don't have a fraction over a fraction anymore. It's just 6 times, well, if I'm in terms of 64ths, I'm going to call this 64 over 64 instead of 1, minus 1 over 64. But then that's 6 times 64 minus 1, which is 63 over 64. Right? I can simplify both 6 and 64 divisible by 2. That leaves me with a 3 and a 32, right? And so then I have 189 over 32. And that, I believe, is our answer. Let's take a look at 19, which is similar. So I'm going to leave that formula right there. 19 is the sum from we've got j equals 0 to 7 of negative 1/2 to the j. Okay? So we're going to need to manipulate this, right? I want it to start at 1, and so I can do that by calling this j equals 1 and going to 8 instead of stopping at 7. That way I'm just going over the same number of terms, just starting at 1 and ending at 8 instead of starting at 0 and ending at 7. Right? My ratio is going to be the same. But again, if this is j, the power starts at 0, this power needs to start at 0, so this is simply j minus 1, and I have it in that format. Right? So I can use this then. I have a, but a is just 1. If there's nothing written here, it's just a 1. So it's 1 minus r, which is negative 1/2, to the n is now 8 over 1 minus r, which is negative 1/2. Be careful with these negatives, right? It's easy to screw these up. Negative 1/2 to the 8th is going to be positive, but then I still have a minus here, so it's still going to be 1 minus. 1 to the 8th is just 1. 2 to the 8th is 2, 4, 8, 16, 32, 64, 128, 256. Okay. 1 minus a negative, that's a plus, so I get 1/2 plus 1, 1 plus 1/2, that's 3/2. Okay. So I have, in the same way that I did last time, I'm going to call 1 256 over 256. Minus 1 is 255 over 256. And since I'm over 3/2, I'm going to flip that and call it times 2/3. Right? I can simplify the 2 and the 256, gives me 128. 255 divided by 3 is divisible by 3, so that gives me a 1 there. And that gives me an 80, 1, 2, five, of course. Yeah. And therefore I have 85 over 128. Can't simplify that anymore, so that's my final solution. Okay. Good. Okay, let's look at the rest of them. I think in the chapter were all infinite sums now. Those were partial sums. Infinite sums, let's look at take a look at 21. I have the sum of j equals 1 to infinity of 3 times 1/2 to the j minus 1. Okay? And again, we have a formula for this. The infinite sum is just s, the sum is equal to, and it's always a, the very first term that you get, right, over 1 minus r. Right. The numerator, you don't get the 1 minus r to the n anymore. It's just a over 1 minus r. Right. And so I can write this then as a is 3. 1 minus r is 1 minus 1/2. So this is 3. 1 minus 1/2 is 1/2. 3 divided by 1/2 is the same as 3 times 2, and so I get 6. You can actually see that these infinite sums are often easier than the partial sums. So let's take a look at 22, and then I'll leave the rest to you guys. That should definitely get you through, I think, the rest of the homework. But I did just say definitely, and then I think in the same sentence, so let me know if it doesn't, right? The sum k equals 1 to infinity of 2 to the, times 3/5 raised to the k minus 1. Okay. So again, I'm going to use the same formula. So it's a divided by 1 minus r. 1 minus 3/5 is 5/5 minus 3/5, which is 2/5. So that's the same thing as 2 multiplied by 5/2, or 5. Right. So hopefully that's helpful. Hopefully that gets you through the rest of the homework, or the entirety of the homework. Don't forget to get into discussions and talk about the test 3 review, and then I'll put one up for the final review later. Way to go. I think my 127 classes are doing quite well, staying with it, so kudos to you guys. We're almost there, and I'll see you next video.